Welcome to a More Insights Data Center podcast. My name is Matt Kimball. I am a VP and Principal Analyst covering all things data center, but especially fond of compute and storage. And today I have a couple of guests with me that are going to talk about enterprise IT and some of the things we're seeing in the data-centric enterprise and what's driving the adoption of new technologies. But before I bring him in, I want to talk about, I just want to set this up a little bit, give a little bit of context. Way back in 2005, 2006, Intel and AMD and others in the market started shipping these multi-core processors, these things called multi-core, which introduced virtualization into the marketplace, made it mainstream. And as we saw these servers ship out with more and more cores, we noticed that the size of the servers were starting to shrink. You know, back in the day, there were 16-way servers, that's 16 processors that handled big workloads, like big data warehouses and the such. And that eventually gave way, and it was just 8-way servers and down. And it continued to shrink. And today we're sitting at a place where we see single socket servers, dual socket servers, and 4-socket servers. And it feels like, to me, that 4-socket servers have been here for a long time, and they are here for the long haul to handle a lot of the enterprise data-centric needs. So with that said, I have a couple of experts I've brought into the discussion from Intel and Dell to talk about this. First, I want to introduce Gilberto. Gilberto Vargas is a general manager of data center and AI for global sales and marketing at Intel, based out of Santa Clara, or let's just say at the Bay Area. Gilberto, thank you for joining the podcast today.
Yeah, thanks for having me. Pleasure to be here.
Yeah, thanks. And second is no stranger to More Insights and Strategy podcasts. He's used to be a regular before we had to kick him off for, well, we don't want to talk about that, but Jonathan Seckler, who is the head of server and solutions marketing at Dell. In all seriousness, Jonathan is a great friend of the podcast and of More Insights. We've had a lot of chats. Jonathan, great to see you here as well.
Good to see you too. Although I'm a little concerned about that introduction, but appreciate it.
We'll cover that offline. And by the way, Jonathan, we were just talking pre-podcast. Has been in Austin forever, but he recently relocated up to Eugene, Oregon. So we hope you're enjoying the beautiful summer up there and not the 104-degree weather down here, Jonathan.
It was 51 degrees this morning, Matt. So yes, no complaints from me.
Oh, you're making me cry. All right. Hey, we could go on forever about personal stuff, but hey, you heard my intro, guys. You know, this kind of continual shrink of the server. You know, I call it stubbornly stopping at 4-socket, but really hasn't. I mean, 4-socket serves a purpose, right? Before we get into, you know, the notion of 4-socket, what are y'all seeing out, you know, with your customers as you talk to them around the kind of needs of the data center, you know, the needs of a lot of memory, a lot of processing power, and the workloads that are being supported by those? Who wants to go first?
I'm going to start with Intel. Gilberto?
Let's start with Intel. Yeah.
Give your view. Yeah.
Go ahead, GV. How about you?
Just you know, the new guy on the podcast.
That's right. You get to go first.
Yeah, exactly. No, you know, I think you said it pretty well, Matt. You know, so you know, there's kind of two different forces really happening in the market. I do agree that, you know, as over time, you know, we've seen less of these, you know, higher socket systems, but I do agree that, you know, as our customers are looking more for, you know, having more data closer to them, and how to, especially now with the growth of AI, and how do they translate that data actually into insights. You're gonna see, I think, that line at, you know, 4 sockets, and our customers actually get a lot of benefits from having a 4-socket system instead of, you know, continuing to sell down to or go down to 2 sockets and 1 socket. I think there's going to be room for both. You know, you're going to see more 1-socket systems, and you're going to see a steady continuance of 4-socket systems as customers try to keep that data as close to possible and turn that into quick insights.
Yeah, I would agree. I think that, you know, the way to think about this is really, you know, if you start, you know, back in the 90s when I started in this industry, you know, there was only a single core per CPU, And so, compute was probably the limiting factor, the ability just to process and do the math, literally do the math inside the server. And so sockets grew as a function of the need for that additional math. With multi-core processors, with virtualization technologies the way they are, all of that math is now condensed into just a more and more complex multi-core system. And the limiting factors now change to memory, right? And I think Gilberto just says it really well. Keeping the data close to where the math is going on, and needing that extra memory. And I think that while we do see larger and larger systems that still exist out there, I think that as we move forward, a 4-socket server is probably the largest you might ever need to do most, the lion's share of the kind of compute in the data center you would need to use.
Yeah, to me, it's kind of interesting that, if all you do is read, well, folks like me, right, on forums or whoever you're going to read, right, everything is cloud native and everything is AI,
right.
everything is GPUs, and we all think scale out, scale out, scale out, forgetting that, these are very, very large companies that have a lot of legacy data, and have these applications that have been in existence for a long time, even though they've been maybe refactored or at least updated, still rely on a lot of that memory and a lot of that IO that you only get out of a 4-socket platform, and that feeds a lot of our kind of digitally transformed operations, right? Do you both see? Let's start with you this time, Jonathan, because you're Dell. You may be a little bit on the front end of the customer touch point. Do you see these these workloads, these line of business applications, other applications like VDI? Do you see them as kind of still being housed on 4-socket boxes, or?
Yeah, I think, like I said, I think that the 4-socket architecture is probably the largest manageable entity you could put in a data center. When you get beyond 4, things do get more complex, and you need specialized, resources and specialized knowledge to deal with it. But we are seeing, as customers, especially as they put applications in front of their end users, that they're holding back and keeping in the data center, virtualized desktop infrastructure type stuff, and some of the larger legacy databases where you've got just millions of rows of information, and you want to keep it all in memory. Yeah, I think the 4-socket server is here to stay in that instance, for sure.
What do you see, GV? I mean, it's interesting. Intel is unique in that you support these 4-socket platforms. What does Intel see that makes Intel say, talk about Intel like a person, but organizationally, what do you see that makes you go, what, we've got to not only invest, but kind of build upon the goodness we build into these 4-socket platforms?
Yeah, what we hear a lot from our customers is, there's still a set of, pretty mission critical business needs around keeping that data close to themselves and even to their end customers. So, we do a lot of work, for example, with SAP HANA, and, of, trying to make sure that our joint customers, with Dell, with SAP, and with Intel, have that clear access, and what that means to for a lot of customers is exactly more memory per server, more memory per socket. SAP just recently said they're doing now with Sapphire Rapids and the Dell 4-socket system 2 terabytes per socket. That's up to 8 terabytes. That's data that's readily available for our customers to go again, gain insights from it.
And do you find that the kind of 4-socket approach compared with two sockets, where is it NUMA issues? Is it kind of accessing that memory fast and quickly, and your reads and writes and gets and all that kind of, that's where the efficiency comes in? Or is it manageability? Is it cost? Is it all of the above?
Yeah, it is actually all of the above. There's certainly a cost improvement. There is even a sustainability improvement, right? As you can actually do a consolidation of servers and therefore use less power, and that can help our customers meet the sustainability goals that they have, and we all have sustainability goals. But it is also that manageability and increasing that quick access between all the sockets instead of going through multiple servers.
Yeah, I mean, actually, that's a really good point in terms of the manageability. So, the trade-off in the data center, especially when you have so many choices these days, right, is how it's your support contracts. It is the ability to manage the devices themselves, et cetera. And when you've got something like a PowerEdge, our 860 or an R960 kind of system, you're managing, that's one warranty, that's one support contract, that's one management domain inside your system, versus having two or maybe even four separate domains. And I think that's actually at least a convenience to our IT customers, right? And then on top of that, you go back to what you were saying about keeping data close. I really think that's an important thing. Having one large database in a huge memory store that can be acted on by the literally hundreds of cores that are available in a 4-socket system, versus having to split that up or replicate it across multiple servers is, I think, there's certainly trade-offs with RAS, reliability, availability type features, but these things are so rock solid that it makes perfect sense to do that.
Yeah,
in a single server.
I have to think one of the obvious, and you bring it up with SAP, or you at least hint at it with SAP, obvious use cases, analytics, right? And having the best performing analytics, right? To what you're saying, if I can all my data sitting in memory and be able to access that more quickly in one system versus having to go across.
And I think there's a security issue too, right? I mean, you talk about threat surface, right? I mean, it's a single server, at least you can, it's a little bit easier to protect than multiple servers. And with all the, again, going back to all the devices that you have to manage, having trying to manage the databases and the applications, especially these big mission critical ones, in fewer fewer systems is a benefit.
Yeah. Both security and regulation, right, Jonathan?
And regulation. That's a good point too. Yeah.
That's a good point, because as you think about it too, right? When we talk about data centric, and kind of everything we've been talking about is having your data closer to you. We're hackers trying to get to, right? I mean, right. So to what you're saying, if you can keep that in kind of fewer and reduce that surface area, certainly it's a stronger security posture for it. Speaking of security, y'all have done quite a bit, both Dell and Intel. Talk to me about, there's this thing called Fort Zero. There's a whole bunch that Dell announced back at Dell Tech World, which is great. I know that, GV and Sapphire Rapids, y'all did a lot to Xeon around security. Talk to me individually and then collectively, right? Like, what did you do kind of at the silicon level, at the platform level, and how does that work together kind of to make a 1 + 1 = 3 kind of equation for security? And you can choose, let's start at the silicon level. Again, let's let the rookie go first.
Yeah, so with Sapphire Rapids, so actually with our 3rd gen Xeon processor, we introduced software guard extension, so SGX, right? And the idea really being, how do we increase data protection that's both at rest and in motion with a hardware level of protection, so a silicon level of protection for data. And then as we went into Sapphire Rapids for and into our next generation, our 4th generation now, that's codenamed Sapphire Rapids. And as we went to 5th generation, we're also introducing TDX, our latest security features for the silicon. So we're really trying to help our customers have a peace of mind on data encryption and protection, as and from a silicon perspective, so that it complements, what Dell is doing from an overall system perspective.
Mm-hmm.
Yeah. We've partnered with Intel on a number of areas. I mean, the silicon security extensions is one example. Another one that is really important to the U.S. government, and I think really should be important to more people, is the idea of managing your boot process so that you're not beholden on third-party certificates. And so what that means then is that you need to use the UEFI boot as opposed to the kind of legacy boot process that is out there. And we've partnered with Intel to manage that, and then also to be able to customize that boot process so that you can use your own custom certificates.
Mm-hmm.
The traditional, I think, standard way of doing it is to use a third-party certificate, but the downside is if that certificate is ever compromised, it's really, really difficult to recover if from a if the boot BIOS itself is compromised.
Yep.
And so now with UEFI boot, we can go through this safe boot process. That's part of the security. And I think then going up to the next level up is this idea where we've got to do more to provide a zero trust capable ecosystem out there. And so we've partnered with Intel and others, on this idea called Fort Zero, which is a partner ecosystem, including Intel and Dell, to create and make sure that our infrastructure can be enabled for zero trust. Zero trust is the government referenced as architecture that suggests that instead of allowing any kind of conditional access to a system, you only allow trust access of any sort once you've verified and can confirm the credentials of the person or the device that is asking for access.
Mm-hmm.
And we'll actually be rolling out a service offering that will lower the barrier to zero trust adoption. This is something that is going to be a requirement and for working with federal or governmental agencies worldwide. And Dell is working with partners to come up with to take on the integration and orchestration work that you need to put in the effort to make your whole environment zero trust enabled.
Yeah, I really like this. This is we did some work on this, more insights, and we found that the average enterprise IT organization deploys over 40-point security solutions. I speak with enterprise organizations that have well over 100-point security solutions, and nothing is air gapped, right? I mean, there are all of these vulnerabilities that exist within a lot of IT organizations, and so, and by the way, everybody has their favorite vendor they like to work with when it comes to security. And so what I love about what y'all are doing, number one, the Intel Dell kind of connection point of boot to that trusted environment, assure that those millions of lines of code that execute before boot are pristine and authentic, and you're safe when you come up. That coupled with this, hey, Mr. and Mrs. Miss Customer, you use the solutions you need, or use this curated solution that's been tested and proven to be gap free. We're not going to force a single stack on you. You go, use these best of breed and make it work for you. It speaks to what you both do from an ecosystem perspective, right? And that is,
right.
You don't claim to be the sole answer, right? But you claim to be the kind of the integration point for a lot of these solutions, which is fantastic.
I think you're saying that, you said the key word there, Matt, a couple of times, which is really providing solutions to our customers, right? So not just, like you said, not just saying here's, the one thing that everybody's going to use, but really try to identify what are they looking for and provide that solution. I talked about, Intel SGX, and, we believe it's the most researched, the most updated, the most deployed confidential computer technology in data center markets today. But one of the things that we wanted to make sure is that there was very limited impact to performance, right? So how do we provide that security solution without impacting the performance of the data center and what our customers need to do?
Right.
And that's cool because, you know, a lot of the, especially in the 4-socket space, you're talking about, you know, a lot of the workloads you're supporting are real-time analytics, VDI, or where latency is an issue, right? And 2 to 3% hit on performance can mean the difference. Could mean a lot of money to a high frequency trader, could mean a lot of difference to, you know, a big genomics model that you're trying to process. I mean, there are a lot of, there's a real significance to those lost cycles that get spent elsewhere. And that's a good segue into Intel. You guys did some really cool stuff in Sapphire Rapids that I think goes underreported or under kind of spoken to, and that is the use of these acceleration engines to offload some critical functions that free up the CPU to allow for better workload support. You know, you've got QAT, which has been around for a while, but you beefed it up and you know, gave it as created as a separate encryption or separate engine. Load balancing, streaming. GV, talk to this a little bit, and after you do, I want to, Jonathan, if you have any thoughts on how that plays out, I'd love to hear your thoughts on that too.
Yeah,
Sure.
you know, as our engineering team was figuring out our fourth Gen Z on Sapphire Rapids, they really took a workload first approach to that part. So we're very, very proud of that. And instead of focusing on, you know, the synthetic benchmarks out there and how do we just, you know, score the highest we can, they really looked at specific workloads that today are either starting to or already have, you know, some kind of acceleration function that is happening just based on how frequently they're used. So, you know, what we did with Sapphire Rapids is, you know, one, we said, hey, we have to deliver the regular performance improvements that we do generation on generation. We're very proud to, you know, we've quoted the greater than 50% general performance gains on Sapphire Rapids. But then, as you said, Matt, we also came up with these accelerators for those specific, you know, high frequency workloads. We have AMX, which is our AI acceleration. You know, it offloads operations like matrix multiplication. It gives us, you know, 10x the performance on inference and training. If you don't need a dedicated hardware for AI, we think fourth Gen Xeon, it's a great part for that, just given the significant increase in performance. Data compression with QAT. We have the dynamic load balancer, which is balancing traffic across multiple CPUs and CPU cores. Data streaming, so offloading a lot of these, you know, data streaming workloads. And then lastly, and not least, in-memory analytics, so accelerating performance on databases and data analytics. So the combination of all these different processors, depending on what accelerators, depending on what you're doing, can give you some pretty significant improvement without having to get an independent or separate accelerator for your server, for your data center.
Yeah. You know, and you mentioned the AI, which is a kind of the up and coming cool kid on the block when it comes to.
No one ever talks about AI. What are you talking about?
Exactly. and the thing about AI is that while I think the training applications are what seem very sexy, you know, with the big massive servers with lots of accelerators embedded into them, et cetera. Reality is that most interactions with AI are going to be through putting that data out and using it in an application, you know, out there in the cloud or in the edge or at the edge somewhere where it's in an inferencing model where you're applying new data to the model to get an answer, and you know those applications aren't necessarily big servers, right? They're going to be servers without all those accelerators necessarily. They might not have the power or the space to put those big systems in, and you know, with all of the built-in extensions that Intel puts into the scalable Xeon processors, it makes it easier to do that.
Yeah. Sorry, go ahead.
No, please.
Yeah, you know, I was just going to say, and I know we talked a little bit about this in our pre-meeting. You know that so AI still begins with the data preparation component of it, right? You still, you know, gotta ingest it, clean it, label it, make sure that it's ready for that training, and that is data analytics, and it's memory database. It is what 4 sockets and Intel 4th Gen Xeon really shine on, right? Getting that data really close to you, collecting it, and getting it ready for that processing. And then, as you said, Jonathan, there's general purpose AI, which is I'm doing a lot of different things. I wanna train my model. I wanna run the inference on probably smaller parameter models, call it less than 10 billion parameters, and I'm gonna do that on my existing infrastructure on my CPUs and on the Dell system. Or I'm going to have a fully dedicated only for AI training model. I'm training 176 billion parameters, and yes, I'm going to use either a GPU or an accelerator like our Habana Gaudi accelerator that is purposely built specifically for that, right? But I think over time, and now you're getting a little into my personal opinion, you're going to have the enterprise is really going to be looking at smaller models. As you said, Jonathan, it's going to be this, running the inference on my unique data that I want to host close to me. I want it to be secure so no one has access to it. The model itself and the parameters and the recommendations need to be secure. And I'm going to be running that on my existing infrastructure. There'll be these big training models, but once they're trained, I just want to run it and I want to get insights from it.
Right.
So 2 things on that. First, we set a record for 2023. We waited 28 minutes before talking about AI. Hats off to us.
All right.
That's awesome. Second, I have to say,
where's our trophy?
In the mail. In the mail.
In the mail. Right.
Secondly, I have to say, you mentioned this, GB, about kind of not focusing on synthetic benchmarks. Yeah, when I looked at Sapphire Rapids initially, one of the things I really appreciated about it was the workload centric view. I actually think Intel did a lot of the hard work up front, building these acceleration engines, putting these little pieces of silicon into the complex and building the offload and enabling the ecosystem, most importantly, to actually use these and make use of them and make them relevant, is a lot harder than just adding a whole bunch more cores, right? Cores can come over time. This stuff, I think, is going to sets up, both Intel, so your next generation, 5th generation with Dell, to have, some pretty amazing parts. And you're raising the bar. We talk about, accelerators, that point where a company needs the accelerator, you're raising the bar more and more as to when those are necessary and when they're not necessary, which is a huge cost savings for companies too. And it looks like Jonathan's about to say something.
I was just wondering, like, when everything is accelerated, what do you call the accelerators? There's so many accelerators in a processor now, right? That
you're right.
You have to come up with a new name.
Yeah, it is kind of our history, though, right? Integrated electronics, right, is what Intel stands for, and this idea that integrating some of these accelerators into our CPU, not yet to the point where you can completely eliminate them for the big models, but as you said, you're raising the bar on when we are raising the bar when accelerators are needed. It's exactly what we're going for, and we're looking, trying to predict, as difficult as that is, what are going to be some of those workloads that are just going to always need an accelerator, Jonathan, to your point, and we want to make sure that we continue to raise that bar. And so AI is an easy one, right? In memory analytics, we think it's an easy one as well, right? But we want to continue to add accelerators.
But speaking of accelerators, so in 16G, you rolled out, you consolidated, you kind of trimmed down the 4-socket portfolio. You took a server out. You have the 860 and the 960, right? And it seems to me that the 960 is that CPU to GPU or CPU to GPU 1-to-1 kind of mapping or matching of accelerator to CPU. Is that, can you
Yeah, well, I think the 960 is, think of it as that is the largest monolithic powered server that you can put together, and it is designed so that it has kind of a 1-to-1 ratio of CPU to GPU, with the right memory and IO, kind of bandwidth, really optimized to provide that everything in the box kitchen sink solution, right? Versus, say, the R860, which is the PowerEdge R860, which is also a 4-socket server, but much more dense and more about the, like I would say more of a data analytics or data-based platform where you have, lots of storage and lots of compute, but maybe not as much space for some of these, esoteric accelerators that, or extra accelerators that, you might want to use somewhere else.
Yeah, I want to make the point too, I mean, we're talking about four socket. Obviously, it's not just a four socket world. It's a two socket and one socket world too. But I think all of this is really important. I'd like to get your thoughts on it. I've been in IT, and kind of the way I've looked at the world is, I set my standards, my data center standards around my most demanding workloads, and everything kind of cascades down off of that, right? And so while four socket is not the only platform that is in the data center, it's not even the majority of the platforms in the data center, it sets the direction of where the data center is going, right? Or where my server rooms are going, right? I kind of design everything off those four sockets. And I think it's interesting, and I think it's smart, kind of the choices that were made and the strategy was made around kind of support for these and ensuring that these most demanding workloads can be met. But that cascades down through, the relationship between Intel and Dell, down through single socket and dual socket servers as well, right? I mean, you've got a healthy portfolio, obviously, across those.
Yeah, absolutely. I think, we realized, I think about 8 years ago that, that the data center and the cloud as well, all of the different alternatives that customers have where they can place their applications or where they can do their compute. And what we learned is that there's no such thing as one size fits all, for sure. And as applications become more varied, so does the infrastructure needed to support them. So, we worked very, very closely with Intel to make sure that we've built, hardware form factors that match the applications they're designed for. So that's why you see, four socket systems, which we're talking about today with Intel, but also why you see things like the PowerEdge XR4000 or the VxRail version at the VDI 4000, which are very, very small systems for edge deployments or telco that are also based on Intel. So definitely an important consideration as you're building out your data centers, that the infrastructure has to match the workload and vice versa.
Yeah. Yeah, it is, and I think you can expand that comment, Jonathan, even to the cloud, right? How do our customers are thinking through not only, one socket, two socket, four socket, but even cloud on-prem and that entire mix. And there clearly isn't one size fits all, 10 years ago, people were saying everything's going to go to the cloud. It's going to be 100% cloud. And, that's clearly now, I think pretty clear it's not going to be the case. There are workloads that fit great in that environment. There are workloads that fit, great on-prem. And then, the Dell and Intel partnership is so great because we really think through that, what is it that the end customer needs, and try to provide that portfolio of options so that they can meet not only what goes into the cloud, not only what can be done with a one socket part, but also those mission critical, high performance, high memory bandwidth systems that they need, or workloads that they need, and what those four socket systems will address.
And by the way, 17 years ago, they said virtualization was going to shrink the data center down by a quarter of what it is, and we see how that worked out, right? So I don't buy any of that.
There doesn't seem to be a limit on the demand for compute, right?
No,
it's just how to best address it, right? And with AI, I mean, it's clear this is going to continue to grow, right?
Yeah.
So now the question just becomes, how do our customers address that, and again, solve their issues, solve their problems?
Yeah, and I like how y'all have worked together to build that, kind of as you mentioned, the edge to cloud to core data center, kind of that portfolio that kind of spans all of those and allows for those workloads to be run. You talk about inferencing at the edge, or even the big honking AI box you introduced back at Dell Tech World, right? I mean, it's like you are truly spanning the needs. And I noticed GV, we didn't talk about this before, but I thought it was interesting and I thought it was smart. You know, if it feels like in Sapphire Rapids, fourth generation, sorry, it's still Sapphire Rapids to me. You know, you really embrace the notion of the single socket enterprise platform and kind of the scale out platform. And it's good to see that. And I'm guessing it's like that's something you'll expand upon in fifth generation as you kind of move forward as well. That seems like a smart play for you.
Yeah, spot on. We're going to continue expanding it, as you said, on fifth generation and beyond. And it's really, you know, as the number of cores grow and as the workloads that are, you know, especially designed for those, you know, really high core count, you know, systems expands, then we want to make sure that we're there to meet those needs. So, you know, we've been talking about one socket for many years, right? Sure. And we've seen, you know, the growth of those workloads. It is growing over time. So we're going to be there to make sure that our customers have the right options and the right SKUs.
Hey, let me ask you both this. This will be my last question, then I have a couple of lightning round questions for you. So, as a service, two things you can't talk about in 2023, or two things you have to talk about in podcasts: AI and as a service.
Right.
We've got Apex and Intel. You know, when you released Sapphire Rapids, I don't know how broad this news was, but you know, you had these capabilities to turn on acceleration engines later on, even after acquiring servers, you know, if you felt the need. So kind of almost as a service at the silicon level. This is just a personal, this is not a Dell official or Intel. Do you see a point where, you know, a customer buys, say a 960 through Apex, and, you know, you ship it with a full complement of cores, and they turn on and off cores as kind of consumption requires over time? And what's the future of as a service look like, I guess? Does it go all the way down to silicon, or?
Yeah, so since I'm the rookie, I'll start again.
Embrace the rule. I love it.
Yeah, exactly. Embrace the rule. I do believe that is the case. Look, I talked earlier about everybody said that, you know, the world was moving to cloud, and we see that, you know, cloud will continue to grow, but the on-prem business continues to grow as well, and there's a place for each. There are some things about cloud that our customers will continue to expect. On-demand performance is one of them. You know, I can just, you know, I can increase or reduce or rebalance my performance as I go, instead of having to buy, you know, a new server with max capabilities and hope that I use, you know, X% of it. Yeah. And Dell and Intel, and, you know, a lot of the work that we did is starting with conversations that we're having with Dell about what they need from us and what their customers need. We're trying to figure out how to provide some of those benefits of the cloud model, but still give customers the choice that they need to keep their data or their compute on-prem. So provide the best of both worlds. So I do believe that over time, you're going to see Intel more and more offer other capabilities as a service to our customers.
Like burstiness, elasticity kind of thing. Yeah.
Yeah, I think, you know, as a service, as you know, to your point, you know, you have to talk about it. The world has changed, right? I think, you know, people lease their cars. They don't necessarily buy them. They lease their music. They don't necessarily buy, you know, CDs or vinyl as much as they used to anyway. And I think that extends into IT as well. I think this latest generation of IT buyers that we talk to, you know, they are the first real generation that grew up with IT. You know, grew up with computers, grew up with cell phones, grew up with the internet, and so yeah, they're used to that on-demand. You know, when I need it, it's their kind of capability. So, you know, that's the goal, is to meet them where they're at. Because I think that's, to your point, that is the future of IT. Is it's going to be increasingly an on-demand kind of model.
Yeah.
By the way, you're going to have to explain to some of your users what a vinyl is.
That's
so you have that. You know,
all of our hipster viewers will totally know what we're talking about.
That's true. The hipsters will. So that leads me to, I'm going to leave it at one lightning round question. So, well, two parts to it though. favorite band and favorite song from the 70s or the 80s. You get to choose the decade. Putting you on the spot. Jonathan, we'll start with you because we've been picking on GV this whole time to go first.
Yeah. So 1980s. I'm gonna go with 1980s because that's when I grew up. Three favorite bands. I referred to them as the three Bs. There's David Bowie. There's David Byrne from the Talking
Oh,
Heads.
yeah.
And for those of you who grew up in Houston, David Bean, who is the lead singer for a local band in Houston called the Judies.
Oh.
And that was my playlist, or what passes for a playlist, a mixtape in the
Very good.
1980s. Yeah,
Very
there you
good.
go.
Very good. I like it. What was your favorite song? Did you have a favorite song from there that like you hear it and it immediately brings you back?
Burning Down the House.
All right. Nice.
Yeah.
Nice. I like it. GV?
Yeah, so I'm more of a hip hop kind of person. So I'm gonna go and I actually
You're the young one of the crew, is what you're saying.
I don't no, not at all. But I am but I will say I through most of the 1980s I only spoke Spanish. So I'm originally from Nicaragua, so I mostly spoke Spanish. But if I had to choose a 1980s group, I'd go with something like a Tribe Called Quest.
Ooh, nice.
Oh, there you go. Yeah.
Very influential, great music, just incredible lyrics. So I've always loved their music.
Love it. Okay. I like it. We can give you a waiver if you want to move into the 90s or even the early 2000s. We'll let you do that. Tribe Called Quest. What are your couple of other hip hop groups you like?
Oh man, it's it's all of the what you would expect from a top hip hop groups or top hip hop solo acts. I was a huge fan of the whole 90s hip hop scene.
All right.
East Coast, West Coast, the whole thing. And not sure I wanna get into the details here with that crowd, but I was a huge fan of all that.
Right on. Excellent. Excellent. Jonathan, I never got into hip hop, but Talking Heads and Bowie were my first two loves, and then U2 and REM came on after that. But I'd have gone a bit earlier on the Talking Heads. I would have gone with more songs about buildings and food from 1978. It was my favorite album by them. So
awesome.
I'm a big fan of U2 as well. I thought they were great. Yeah.
They were pretty amazing. Anyway, hey gents, thank you so much for taking the time and chatting. It's good to kind of talk about, like I said, while everybody wants to talk about cloud and AI and the what is kind of generates a lot of press today, what we talked about really is what is powering the enterprise data center. So there's a lot of relevance here. I appreciate your thoughts and your views.